Objects and classes. Pretty big lecture today. Content-wise, I tried to trim this one down a bit just so I can go slower. I know I go at a quick pace. This is one of those cases where I have to slow down because this is new concept, very brand new content. Unit testing, that's not too much of a stretch, I don't think, from writing a main method and calling your code to putting your test code in unit testing and do automated testing. But this is brand new. We're really getting into the new 1.16 content, so the pace will slow down a little bit. This is important. Toldfish knows he's got the inside scoop. This is important. Not that everything I say isn't important, of course, maybe. But this one especially, if you don't really get this lecture down, if you don't understand the concepts here, everything we do from here on is going to use classes. So this isn't something that you can just be kind of comfortable with. You really have to have this down. And we'll spend a few lectures, really the next 4 lectures are talking about the same concept. We'll also talk about memory, but we'll talk about it in the context of classes and objects. So let's get into this. The lecture question today is related to rhyming, and this is the first lecture question. I've warned you, if you're reading ahead in the lectures, the lecture questions are subject to change until the grader is posted in AutoLab. So this grader went live about an hour ago, and that's when I posted the new lecture question for today. So it's not the lecture question that you saw if you looked ahead in the slides. This lecture question ties into the rhyming dictionary homework. So if you want some more information about what we're talking about here and what this really means, check out that handout. Even if you don't plan on doing that assignment, at least get familiar with it so you can make an informed decision as to which assignment you want to tackle, or if you want to tackle both and get one of your what did I call them? Homework expansions? Is that the wording I went with this semester? Homework expansions, I believe. Done. You can do them both. Anyway, this lecture question in a package named Rhymes, create a Scala class. This is our first class that we're going to create instead of an object. A class named Word. Should I choose physics or rhyme? It's up to you what you choose, and you can change your mind up until the deadline. But at least check them both out. You don't have to do both, is my point. And you do have some flexibility there in what you do. And create a class named Word instead of an object, a class, and we'll talk about what classes are, obviously, with a constructor that takes a value of type list of strings representing the sounds of this word, and a method named alliteration length that takes another word as a parameter. So we're going to compare 2 words with each other, which both have lists of strings representing their sounds or their pronunciation, and returns the length of the alliteration, which we're defining as the number of sounds at the beginning of the 2 words that are identical. So for these 2 lists of sounds, for these 2 words, the first 3 sounds are identical, and then the 4th sound is different. So this would have an alliteration length of 3 according to our definition of alliteration length in this assignment. And then the test cases in a package named tests. Write your test words test suite to test this functionality. So you're going to create new words, call alliteration length on various combinations of words, and make sure that you're always returning the correct alliteration length. Okay, so before we talk about classes, let's kind of recap what objects are. I very briefly mentioned what objects are earlier in the semester. Now let's kind of break that apart and give it a little more detail, a little more structure to this definition. I still haven't figured out the last lecture question. I don't want to spend too much time harping on this, but I do, excuse me, but I do strongly recommend that you finish each lecture question before the next lecture. Sometimes that's not quite possible. If you just hit a brick wall and you're not making any progress on the lecture question, don't beat yourself up on it trying to get it before the next lecture. But if you don't have all the content up until this point down in your head and understood, then it's going to be tough to follow the current lectures. It's easy to fall behind in this class if you're not keeping up on the lecture questions. So as long as you gave it an honest effort to complete that lecture question, I wouldn't sweat it too much. Just make sure you're getting caught back up. but you are behind at that point if you haven't finished the lecture question. And there are a lot of students who are, not even doing the lecture questions, just relying on the later deadlines, I hope, and not just ignoring them outright, but make sure you're keeping up on those. So objects have state and behavior, and what do I mean by that? Objects are kind of a container that can store variables and functions. So an object can have variables in it, and it can have functions, and when functions are part of an object, we call them methods, as a little bit of vocab. A method, whenever you hear me say method, if you think of those as functions, I'm not going to blame you too much until we get to the distinction between functions and methods. So far in the class, you've written methods, and we haven't really taken advantage of the fact that objects can have variables in them, but we'll see an example of that in the next slide. So objects have a particular state that they can be in, which is the value stored in each of its variables at any given time. That's what we call the state of that object. If it has a variable that's an int and that int stores the value 7, then that object's state is has the value 7 to an extent. I mean, it can have multiple variables, but that state is defined by the variables in that object. And then the behavior, how does this object behave? Well, that's defined by the methods that can be called on that object. So an object is a collection of variables and functions. That's what an object is. That's what it can have. Variables and functions referred to as its state and its behavior. So here's an object with state. We haven't really played with this yet, but this will be start becoming more and more important. An object with some state. So an object is a collection of variables and methods. Here we have the state of the object defined by its variables. So here we have two variables, x and y of type int, and I'm assigning them initial values of 10 and 7. These variables are outside of all of the methods of this object. So since these variables are outside of any method, so we've declared variables inside methods before, those are not part of the state of the object. But here we're declaring variables outside of all of the methods of the object. It's inside the braces, the definition of the object itself, but it's outside of the definition of any of its methods. So that becomes part of the state of the object, and that state persists across method calls and can be accessed from any of the methods in the object. Inside any of the methods, you're familiar with what the methods are at this point, but inside any of these methods, we can access the state variables of the object using the keyword this. Or in most cases, we can exclude this, the keyword this, and just say x. In this case, we could just say x, and that's fine. But we can use the keyword this to access any of the state variables. And here, whenever double x is called, I want to access the state of the object and multiply the value in x by 2. So when this method is called, it actually has what we call a side effect of modifying the state of the object. What is forking? GitHub fork? That is not related to this lecture. It's not a global variable, but it is. So the scope of these variables is at the object level. If it were outside of the object, it would be a global variable, but Scala doesn't allow that. We don't have those. But anybody who has access to this object, any code that has access to this object, and anywhere within the object itself in any method call will have access to these variables. And these variables persist as long as the object persists, which means if two different pieces of code both call double x, the value of x is going to be 40 after both those calls. So the state of the object can change. Just a reminder, the difference between val and var. I'm using var here, which means these can change. The values stored in x and y can change because they are variables. If I use the keyword val, that means the values cannot change, and that'll be a permanent state of that object. If I said val y of type int equals 7, y is always going to be 7, And it's still technically part of the state of the object, but it's not a state that can be changed. So we can use val and var to kind of distinguish between state that can change and state that can never change. I'm not familiar with the side effect error in IntelliJ. Yeah, so anything would have access to these. So any piece of code in the program would have access to these variables. There's not strictly global variables, but anywhere in your code you could do object with state dot x and access x or y, assuming you have the appropriate import statement. But it's not strictly global. Strictly global would just be anywhere in your code you could type x and access that variable. You do have to give the fully qualified name, object with state dot x. These variables come by many different names. If you've seen classes or objects before, you've heard at least one of these names: instance variables, member variables, fields. I'm going to stick with state variables in this class, and I'll try to be pretty consistent with that. I'll use these terms interchangeably at times. Just to lessen the confusion of this course, I'll stick with state variables. Whenever I refer to a variable that's part of an object's state, I'm going to call it a state variable, just to keep things consistent. You can make the variables private. We won't do that in this class. I actually had a few slides on that in this lecture, but it's kind of irrelevant for the concept. So I actually deleted them for today. But access modifiers, we can talk about them after the lecture for anybody who's interested. You won't see any in this class. I won't use them. In Java, you'll see them all the time. In Scala, it's standard practice to just not use them. But I don't want to spend too much time talking about that, because pretty much everything we do is just going to be public. And then if we want to access that, so anywhere in our code, say we have this other code in another file somewhere, and I'm assuming they're in the same package, so I don't have my package declarations and imports here. But if they're in different packages, we would have to import object with state. And then anywhere in our code that has access to object with state here, I can call that double x. So in this main method, the very first line of code that's executed is just grabbing object with state and calling double x from this object, calling that. And then when I print object with state dot x, I can access that state variable. And when I print this will actually be 20. It's going to go to object with state. It's going to see that that was doubled by calling double x. And anywhere else in my code too, if I have code way further away in some other file somewhere, and it calls object with state dot x and prints that to the screen, it's also going to see that change of 20. So we can change the state from outside of the object itself. Every value in Scala is an object. Everything you work with in Scala is an object. So everything, like if you just type, and hey, I have this set up, I might as well. So for example, every value is an object, which means every value has state and behavior. If I type 7 dot, I guess I have to give it some hints. And 2 double, like the value 7 is an object, so it has state and behavior. Its state is storing that value of 7, and the behavior is all of the methods that I can call on it. So I can call the 2 double method on 7 because 7 is a value, therefore it is an object. Every value is an object. So you can call methods, if there are methods that exist for that object, you can call those methods, access its behavior, and access its internal state if it has state variables. Every value in Scala is an object. This will become more important. This phrase should become more important to you as you learn more about the language and more about our 116 topics. But this is very important to know. I'll remind you about this throughout the semester as it becomes even more and more important as we go through. But every value in Scala is an object. which means every value in Scala has state and behavior in the form of variables and methods. Classes. So let's digest a little bit. Let's take a quick pause here. Any questions about objects before we get into classes? So the new thing here is that objects can have state. It can have variables as part of the object. What was the point of this.x? Is I'm accessing the state of that object. So I have a method. Every method in an object has access to the state of that object. So when I say this, I'm saying this object that we're working with right now, which is the object with state, this object access its x variable, its x state variable, and multiply it by 2. So it's going to access this state variable here. Any variable, when you access it with this dot, you're accessing any variables that are declared in the object, but outside of any of the methods. So we're going to access that x, multiply it by 2, and after this method is called once, x is going to be 20. If we call it again, x will be 40. Call it again, x will be 80. But this means, hey, I'm about to access one of those special variables that are that's outside of this method, but inside the object. Look for an x in there, and then multiply it by 2. Yeah, this is like self in Python, right? Yep, and then it'd be 20, 40, 80. It'll keep multiplying it by 2. Public and private, again, I'll talk about this more after the lecture if somebody wants to talk about it. But public and private, making something private has nothing to do with security. It has everything to do with just readability, so that your other developers on your team know that they shouldn't mess with that method, that they shouldn't call that method. But from a security standpoint, it doesn't stop somebody with malintent from accessing it. You can always access private variables and modify them if you want. It just takes a few extra lines of code to remove the access modifier, but you can do it programmatically. Let's work with objects with state outside of that specific object, still in the same project. Yeah, that's what we did in this main method. So we accessed that, we can access the variable directly because it's public. For those of you thinking of access modifiers, we can also access the behavior of that object. If we're in the same project, we can access the state and behavior of the objects in that project. We do that actually with methods, with behavior, with the math object. So math is an object that has a lot of methods that help us, do math. Math, the object, has a method called ABS, which takes a number, either a double or an int or any other type of number, and returns that same number but without the negation, without the negative. That's the same thing we're doing here. There's object math, def ABS of double returns double equals if input less than 0, negative input, else input. That method exists in Scala in the math object. Actually, maybe it's worth pointing that one out. So math.abs Oh, I forgot this. So it does actually use the Java math, but we have. I forgot Scala uses the Java math class, but this would say, if this were Scala code, I can't edit it. This would say object math, and then we have some state, which are all constants. So we have e, pi, and a few other constant. Oh, I guess those are the only constants defined, and then a lot of methods for what we want to do with the math package. And then math is automatically imported, but then we use the math object in the methods, the behavior of the math object, or its state and its variables to be able to help us write our code. So that's an object that we can access from outside of that object to help us write our code elsewhere in the project. Natural log. We don't mess with natural log in computer science. It's always log based too. It's the only log. Not that I care. I don't have strong opinions about logs, but if you see log in CS, it's almost always log based too. Okay, so those are objects, collections of variables and methods. Those are objects. We've been messing with them the whole 2 weeks of this semester so far. Can you believe it's 2 weeks in already? Crazy. But that's what we've been messing with, is collections of variables and methods, state and behavior. Classes is the new concept, and technically there were objects in JavaScript and Python. You just never really had to think about it too hard. We do have to think about it more when we're talking about classes. So classes are templates that are used to create objects with similar state and behavior. So if we want a lot of objects of the same, what we call the same type, then we're going to create a class, which is a template for creating those objects, where they're going to have the same behavior, but they can have different state. They're each going to have their own copy of their state variables, which can be in different states at any given time. So with a class defined, we're going to define a new type, and then whenever we want an object of that type, we're going to use the keyword new. We're going to say, give me a new object using this class that I wrote. And then that's going to give you a copy of all the state variables and all the behavior of that class in that object. And you can't work with classes directly, but you can create objects from the classes and then work with those objects. You can't have main methods in classes. Main methods have to go in objects in Scala. So even if you write a class, if you want a main method, like if I have this class defined and I want to write a main method, I would say below the class, after the class definition, I would say object item, and then write my main method down there. So here's our first class that we're going to see, and I'll step through this one step at a time. But first, right off the bat, we can see a few things that are familiar from objects. We have state and behavior, except we have some different stuff up here. This we got to talk about. But this is a class which is going to represent some item that a store has available for sale. So when they want to do some accounting, we're going to assume this store has an item for sale, a description for that item, a price for that item, and they want to track, they want to do some inventory and accounting to figure out how many times somebody's purchased this particular type of, this particular item. And since we want to sell more than just one type of item, every item in our store isn't going to have the same price and description. We're going to make this a class so we can create many objects of type item to represent all the different types of items that we sell in this store. And we can also put them on sale, cut the price by 20% as a different behavior. So let's break this apart and see what's going on with this. So with this, I got ahead of my slides a little. So every item, track the times purchased. We're doing that through a method and a state variable. So we have a variable times purchased initiate to 0, and every time the purchase method is called, which would be called as part of, once a cashier hits the register to say, or scans the item and says, hey, we're buying this, the transaction's complete. Somewhere in that process, this purchase method would be called and goes back to the inventory subsystem of the store and say, okay, this was purchased. Let's access this object's times purchased variable and increment it by 1. There's no, for those of you wondering, there's no plus plus in Scala, so we have to do plus equals 1 if we want to increment. So we're going to increment times purchased by 1 just to say, hey, this was purchased. Somebody called my purchase method, so this must have been purchased. We can also call on sale, which is going to access this dot price and cut the price by 20% by multiplying it by 0.8. Yeah, those of you who've done classes in Java, the syntax is a bit different here. So let's talk about this new thing, this strange syntax at the top. You've had a second to stare at it. Okay, you got it? Let's go back there. this right here, this is what we call the constructor of the class. This is a method with special syntax. We define this in the special way where we put it right in the class definition. Class, the keyword, the name of the class, which is going to be the type of the class. So we're going to use this class to create objects of type item. We don't just want one item and one type of item in the store, because then we would make this an object. We're going to make this a class so we can have all different kinds of items in our store. So class, the name of the class, which is going to be the type of the objects that we'll create using this class as a template. And then a parameter list, which is going to be the parameter list for the constructor method. So each class has a constructor method, which is the method that's called whenever you create a new object using this class. So whenever I create a new item using this class, I'm going to call this constructor using the keyword new. I'm going to say new item and give arguments for these parameters, and then that's going to return a new object of type item. So this constructor is going to take a parameter list similar to a method, except we should, I'll say, add not access modifiers. We should declare our variables using either val or var to say whether this value can change or can't change. These technically are optional. I believe it defaults to vanilla val, but I think there's some slight difference. I could be mistaken there. Maybe it just defaults to val. But you should always add these in, only in constructors. Add these in to specify whether these variables can change or not. And any parameter of the constructor will become state variables. So in some languages, if you've seen constructors before, you'll have extra code to say this dot description equals description, this dot price equals price. If you haven't seen that before, just ignore that sentence I said. In Scala, anything in the constructor becomes state variables. So this is the same thing, similar as if we declared these variables down here, just like we did in our objects. But what we do with the constructor and why this is useful is when we want to create objects of the same type that have different initial state. So if the initial state can be different, which it can in this case, if I'm creating an item, each item is going to have a different description and a different price. And I want to be able to supply that information each time I create a new object. I want to say, this item's, maybe I'm selling cereal. This item is description. It will be a delicious cereal, which will not change. I don't expect the description to ever change, so I'm going to declare that as val. If the description does change, I got myself in trouble there. And give it some price. The price can fluctuate as markets change, as inflation takes effect and everything. The price can change, so I'm going to declare that as a variable. But I'm going to give it some price, maybe $4. 4.0, that's going to be my price. But that's different for each item. If I create another item in my store, maybe I want milk with a description of it's milk. What do you expect? And the price is maybe $1.50. I forget what milk prices are. That's going to be different for each object of this type that I create. So whenever the initial state or the absolute state value isn't going to change, when the state can be different, the initial state can be different between objects of this type, we're going to define those state variables in its constructor. And then whoever's creating, whenever you create an object of this type, you can supply the constructor arguments at the time of construction to be able to set those at different values. If there's a state variable that's always going to have the same initial value for every object of this type, then we define it the same way we did with objects, where objects can't have constructors because that doesn't make sense. But we can still declare variables the same way we did with objects if they're always going to be the same initial state for all objects, and we don't want to clutter up the constructor with something that's always going to be the same. Times purchased, it's always going to start at 0, so we put that here because it doesn't matter if it's cereal or milk. The times purchase is always going to be initialized to 0. Let's not force the user to give us a constructor argument for the times purchased. We would add a lot more functionality. I mean, if we were actually implementing a store, we'd be calculating taxes and having shopping carts and being able to come up with print out receipts and stuff. This is just a very small snapshot of a grocery store. Yes, you can access these variables later. You can access them and you can change the price, you can change times purchase, but you can't change the description. But you absolutely can access these variables later. So let's see exactly that too. Let's keep track of each item of times purchased, or will it just keep track of all the items? It'll keep track of the times each item was purchased independently. So if I have, I maybe just because I was looking at my slides just a little bit ago, I actually forgot that my exact examples were cereal and milk on this slide. I just happened to use the same things. I'm just thinking about Mike too much. What can I say? So this sounds weird, but here's our cereal and milk with $3 instead of $4, like I said, and $2 instead of $1.50, like I said in the previous on the previous slide. So this is the syntax that we're going to use to create new items. And I guess with widescreen slides, I could have fit the class on the slide here too. But using this class definition here, we're going to call this constructor whenever we create a new item. So I need to give it a string and a double for its description and price when I create a new item. And I'm going to use this syntax, new item, and then parentheses, we call the constructor, which is named item, the name of the class, and then give it that string and double for the description and price, or at least initial price, of this item in my store. What this returns is an object of type item. And what we did when we created that class of type item, that item class, is we actually defined a brand new type in Scala. Just like int, double, list, map, all the types that we've been working with, array, all these types that we've been working with, we just created ourselves a brand new type that didn't come with Scala. It wasn't prepackaged with the language. It wasn't in a library that we just imported. We actually defined our very own type just like these other types. So when we create new items, it's going to return actually a reference to the object that was created. We'll talk about references next week, so if you don't want to think about that yet, don't worry. And then we're going to store it in a value. In this case, we could use var, but a value of type item. Since we just created our brand new type, we can create values and variables of that type. We can use that type as our parameters in our methods. We can use that type as return values, the return type of methods. We can call methods with this type. We can return methods. We can use return values of that. We can do anything we could do with any other Scala type with the brand new type that we just created. So we're creating a new item, a new object of type item, with a description of cereal and initial price of $3, and storing that in a value named cereal of type item. Same thing with milk, create a value named milk of type item, and create that new object of type item with a description of milk and an initial price of $2. Once we create, and just a quick side note, with something like a list, we did the same thing. We called the lists constructor. I have a slide on this later, but I want to talk about it early and often. We still call the list constructor, but it's set up in a different way where we don't use the keyword new. So when you just said list of 1, 2, 3, 4, you are calling the lists constructor and creating a new object of type list with an initial state of the values 1, 2, 3, 4 in that order. But we're doing it without the new keyword. Just the way that class is set up. It's set up a bit different. Something we don't need to focus on here. So now we have two different objects of type item. Which way do I move here? I'm just covering up the bullet point, right? We have two different objects. Let me just do this. Overthinking it. We have two different objects of type item in our code now. This object that we created, and we stored them in these variables, cereal and milk. So the variables cereal and milk are referring to two different objects that can have different state. They both have variables description and price, but they each have their own copy of description, price, and times purchase. I forgot times purchase. They each have their own copies of the three different state variables. They have the same behavior, so their methods are the same, but their three state variables can store different values and change independently. So let's change some of their behavior. Let's change some of their behavior here. I'm going to call cereal.purchase, cereal.onsale, cereal.purchase. So I purchased cereal twice, which means the cereal object, which has description cereal, price 3, got its purchase and times purchase 0. It got its purchase method called twice. So that incremented its copy of times purchased twice. So its times purchased is going to be 2. That in its copy of times purchased. That does not affect milk at all. So when I print cereal.description has been purchased, cereal.times purchased times, that's going to say cereal has been purchased 2 times. If I called this with milk instead of cereal, it's going to say milk has been purchased 0 times because nobody's purchased milk yet. So nothing's gone to this object and called its purchase method. So nothing has modified its times purchased variable, its state variable. So that state variable is still 0 for milk and 2 for cereal. Cereal also got on sale called. So cereal's price is going to be cut by 20%. It should be $2.20 if I can do my math quick. So its price has changed. So its state variable of price has also been updated. And I also have a method here. Let me jump ahead to this and then go back to that. We can also access its variables directly. If I say milk.price equals 1.5, I can manually change its price to $1.50 instead of 2.0. So maybe I don't want to just put it on sale. Maybe I want to change its price in some other way, or not do strictly 20% off. I can just set its its price to something else. Technically, we can also modify its times purchased in the same way, though we wouldn't want to do that just for the use case of that times purchased variable. Yeah, 240 for the milk. Yeah, not 260, 240. And the last thing here, we have a method which takes a parameter of type item. And this does pretty much the same thing as this print line here. This method, doesn't do much. It's not too useful. But I want to highlight taking a parameter of our new type as an argument. So, as a parameter, and then we'll call it with that argument. So this takes an item, and then whatever is stored in item, we're going to access its description and its price to print out the same information here, but in a little different format for what it's worth. But we're going to take that item and access its state variables to give us some description here. So when I say print price of cereal, this cereal object is going to be given to this method, renamed item, or the variable item is going to be assigned the reference to this object, and then item.description is going to give us the same value as, since cereal was the argument, as cereal.description, which is cereal, and then item.price is going to be the same as cereal.price, which was 240. After we set milk price to 150 and call print price.milk, now item is assigned the reference of the milk object of that particular item. So now it's going to be current price of item dot description. This was called with milk. Current price of milk is milk. The price was updated here, so this 2.0 was overwritten, and it's 1.5. The price is $1.50. Can we connect to classes? Yeah, in various ways, but we're not quite there yet. We need to know what a class is first. Like a class, like a state variable, can be of a type of another class. So I could have this be like a list or something. We can, and we'll also see inheritance, and we'll see different ways of combining classes. So if I forgot that I created an item, a new item for milk, and then created it again, it would not overwrite anything. If I said val milk 2 of type item equals new item of milk 2.0, those are going to be two completely different objects. They'll have the same initial state. They'll both have milk description milk and price 2.0, but they'll be different objects, so they'll change independently. If I change the price of one, it won't change the price of another. But we could, if we did like val milk 2 equals milk, then they will share the same state variables because a new object was not created. CSE 116 is killing me. Dude, it's only week 2. How do we import the class? So we would do, it depends on I didn't put my package declarations here, but we would do import whatever package name it's in, dot item. The same way we import like Scala tests and other things. It's the same way. Yeah, in 116, I mean, it's tough, but if you put in the time, you'll definitely get through it. So we've messed with classes already. Int, double, boolean, list, array, map, etc. Unit, technically. These are all classes, and we just defined our own class. As I mentioned earlier, list, this is calling the list constructor and creating a new object of type list by using the list class and calling its constructor. It's just set up in a way that we don't use the keyword new for this particular class to create objects of this type. We'll use new for the ones that we create. We're not going to get this fancy and set it up like this. You have to use something called companion objects and create separate constructors and initializers and stuff. It's just something we don't need to think about quite yet. But suffice to say, we're doing the same thing. We're just not using the keyword new. So we've been calling constructors and creating classes all along. I'll get to this. I just want to get through the rest of these slides. I just got two little quick side notes that I want to talk about. Constructor, just because you're going to see these if you start the homeworks. After today's lecture, you should be set up for both the homeworks to get started on those. But you'll see this in the physics engine homework. You'll see this equals 0.0. Arguments parameters in constructors can have default values. So if I give these default values, it means if this constructor is not provided with 3 doubles, any remaining doubles are going to be set to 0. So if I say new physics vector of -6, it's going to have the -6 to assign to x. Y and z don't have any arguments here, so they're going to refer to their default values and be set to 0. I could say new physics vector of nothing, and they'll all be set to 0, and I'll get 0, 0, 0 as a physics vector. It's just a convenience feature. Helps out, and just to keep things a little cleaner sometimes. And we can define a toString method. If you print out if you print out an item in that class that we created, you're just going to get item and then some kind of randomish looking stuff. It's not going to be anything useful. But if we create a toString method, we can have the values print out in something more useful. So I create this toString method for a physics vector to get the vectors printed out in a way that we expect vectors to be printed instead of what the default is going to be. Which brings us back to our lecture question. So let's go to this demo and talk about testing classes. Part of your lecture question is to actually test this new class that you're creating. So how are we actually going to test that this state and behavior, especially the behavior here, behaves the way that we want it to behave? So let's jump over to IntelliJ. Resize a few things. And let's write a unit test for, oh, damn it. What's the quickest way to do this? I want to use this window because it's set up, it's the right size that I want. So let me just grab the item class from the examples repo. Scala class. Package lecture, and let's create a unit test for this thing. Oh, a nice feature of IDEs. So I mistyped that. If I go to refactor, rename is what I chose in the menus there. I know you can't see it. It actually gives me, oh, you can't see that part either. Dang it. But it'll give you an option to rename it. And when I rename it, it's going to rename it here. It's going to rename the file name. And it's going to rename anywhere that I use that name throughout all my code. So here I want to test my items. So to test a class, we're going to have to create, UB is not worse than Harvard. If 116, I don't know, I'm jumping in the middle of a conversation here, but if you think 116 is too hard, you're going to get destroyed at Harvard. We go slow compared to them. So I want to test a class. I'm going to have to create objects of that type in order to have something to be able to test. So if I want to test an item, I'm going to create an item. Let's stick with serial of type item equals new item serial. Oh man. Oh my goodness. Problem is I looked at the clock and I know I only have a few minutes. I'm trying to get this in there. And that started getting me nervous. Equals new item milk 2.0. And I'm going to have my errors, so I'm going to do my import. So import the package where it lives, and then the name of the class. And that's going to let me use that in this part of the code. And I can start asserting things. Assert you know what? Let me not do that yet. Let me do serial dot purchase. Serial dot purchase. Serial dot purchase. So I'm going to access some of its behavior, and then I'm going to check that I get what I expect. Assert serial dot times purchase equals 1. Should initially be 0. Milk hasn't been purchased. 1, 2, 3, and just kind of test that the purchase method is doing what I expect it to do. And at the end of that, I want to also verify, so another thing I can check is verify that the times purchased of milk hasn't changed. The state variables of these two items behave independently of each other. So they can, so when we purchase cereal, milk should not change. And let's do one more check. Serial dot on sale and assert math.abs of cereal.price minus 2.4 less than some epsilon, and that's all I need. And now we can run this. And hopefully I'll get green barred here. Should get a green check mark. But the important part to know is to test a class, you have to create objects of that type, and then start accessing its state and behavior for that type. For lecture questions and homework objectives, be cautious accessing any state like this. If you're accessing state, make sure it's defined in the problem description. So today's lecture question does not define what the parameter in the constructor should be named, which means you can't access it in your testing. And this will be important moving forward in the class. If I don't define what something should be named, it can't appear in your unit testing, because at that point you're relying on me naming it the same thing that you named it, which isn't always the case. And just really quick, I want to is more expensive. I just want to give an example of a method that takes another item of type item and returns a Boolean of whether or not this item is more expensive. So I can access the state variables of the calling object. So if I say cereal.is more expensive of milk, I can say this dot price to access the price of this item, whatever item the method was called from, which would be this price from the constructor, and greater than other item, and I can access the price of the other item. I can access those two variables separately using other item, that item, get its price, and get the price of this item. So if I do assert cereal should be more expensive than milk, so cereal dot is more expensive than milk should be true. That method should return true, so my assert should pass. So since cereal is the calling object, when this method is called, this dot price for this specific call, this dot price is the same as cereal dot price in this method. So cereal is the calling method. That's how we're accessing the cereal's behavior through this method. So this is referring to the same object as cereal. This dot description in this method for that call is going to be cereal. This dot price is cereal's price. Other item in this case is going to be milk. So this is the same as saying milk dot price for this example. And if we reverse this will be the last example, then I'll switch it to Q&A. If I reverse this, so milk should not be more expensive than cereal. Now the calling object is milk, so this dot price is going to be milk's price, and other item dot price is going to be cereal's price, because I switched the calling object and the argument object. The calling object of the method is always going to be this. The argument is always going to be the other item in this example. All right, so let's cut lecture content there. Back to chat. So you should be able to go to the repo now if you pull. If you click this in your examples repo, click this button, you'll be able to see the examples that we just went through. So yeah, that's exactly what I did. I pushed it to GitHub. So when you went through the lab today, you cloned this repo and you got all this code. Now, if you go to that same project and click this blue arrow, you'll have the code that you saw me just edit, the code that I just wrote in class. I'll try to do that after each lecture if I do code outside of the repo or I add to it. I'll try to remember to do that or remind me each time. Someone mentioned it on Wednesday when I did the anagrams, and I neglected to do it until now. So I want to make sure I did that before we go too far. Can you clarify the lecture question? It's a bit confusing. What's asking for? For the lecture question, it should be fairly confusing if you haven't read the rhyming dictionary handout. So if it's too confusing, make sure you read that and get familiar with how we're defining rhymes. So rhymes are pretty tricky in the homework. That's why it's a homework assignment, and this one's a lecture question. Rhymes are a lot trickier than alliterations. So this is meant to get your feet wet before diving into that homework. Or if you don't like this lecture question, start thinking about physics engine. And spoiler warning, Monday's lecture question, like 95% sure it's going to be about the physics engine. I got the question like mostly written. I'm kind of happy with it. I want to tweak it a little bit and then have that lead into the homework. And that was one of the complaints from last semester, is that the lecture questions, if they led into the homeworks a little more, it would lower the amount of things that you have to think about. Social distance. And Zybooks is easier than the slides. Don't you have to pay for Zybooks though? And there's no Zybook that's going to cover the content of this class. It's one disadvantage of moving. So we moved to a new language and restructured this course a few years back. But it doesn't, there's not a lot of established stuff out there that we can just draw from, like a Zybooks, for example. Looking for people to have a constructive convo about the lecture question. You can always, usually for each lecture question, especially the ones that hit you a little harder, there's usually good conversation on Discord. Go to the CSE 116 channel in the Discord server. There's usually people talking about it. There might be right now, for all I know. Slandering in Twitch chat. Wait, who was slandering? Do I gotta mess someone up? Let me add them. I'll take care of them. They're slandering. Unless they're slandering me. I mean, I'm not as concerned about that. Arcantes, my personal opinion, I don't think any certifications are worth it. Unless you're going into something like IT, for example, they really want to see certificates. If you're getting into software engineering, my personal opinion, other professors disagree, but my opinion is that none of the certifications matter at all. Who am I going to get into a level-headed debate with? Whoever you want. Well, yeah, I'm not going to talk about my colleagues. It's not bad things anyway. Comparing 191 professors. Takes a word as parameter means string. No, I do mean takes a word as a parameter. I will be careful with my language on each one of those. It does take a word as a parameter, which is the new type that you're creating in this lecture question. So the class of type word has a method that takes as a parameter another instance, another object of type word. That's why I did that item example at the end of lecture. So we wrote a method in the item class that actually takes another item, an object of type item. So this is a word accepting another word, not strings. But they do each have a list of strings that you can access to access their sounds. And then you can start checking how many sounds that they start with are identical. In this case, 3. You'll iterate, check the first sound, they're the same. Okay, that's 1. Second sound, they're the same, that's 2. Third sound, they're the same, that's 3. Fourth sound, they're different, so we're going to return 3. And there are, of course, some 116 level challenges in that. How do I iterate over 2 lists simultaneously? How do I stop when I'm done? How do I stop counting after I'm done? Etc. But that's all good old programming stuff that you know. CSE XOR sleep. I feel you on that one. What's the main difference between objects and classes? Oh my. So let me go to the beginning of the slides. The main difference, the quick one-liner. Every value in Scala is an object, so we can only work with objects. That's it. We don't work with classes. Classes are used to create objects. So you create a class, like we'll create this word class in the lecture question, which is going to be used to create objects of type word. In Scala, there's an int class, which is a class which is used to create objects of type int, except we don't use the keyword new to create ints because we have some special syntax to handle that. The double class is used to create objects of type double. The list class is used to create objects of type list. But we always work with the objects in our code. The classes are just there to help us create more objects with with the same behavior and similar state, at least the same state variables, which can store different values in each object. For example, if you create two lists, like in this lecture question, you'll have two lists you're working with. You have two objects of type list, but their state variables are going to be different because they all have different values in their lists. You can't have multiple lists in your program that all have the same exact state. That would be really limiting in what we could do. But we can have multiple lists, multiple objects of type list defined by that list class, but they can have different state. Even though they have the same behavior, list.length is going to have the same behavior no matter what, but its actual output is going to depend on the state of that list. In this case, the number of elements that list currently contains, that list object currently contains. But all the behavior and the variables are defined by the class. Toadfish is back. What should you do when you hit a brick wall in that lecture question? I always recommend taking a break. Just step away from it. Do literally anything else. Just step away from the thing for a little bit. I recommend that in any programming. When you're stuck programming or stuck with any really difficult problem that takes a lot of brain power, just step away. And then come back to it later. Usually when you step away or if you take a nap or something, it'll start hitting you. Your brain needs time to digest all this content, really. You can't just bash. This isn't a course you can do by brute force. Just take a break. That's why I have the very generous deadlines. If you need them, I recommend you do everything you can to meet the deadline. But if you do hit that brick wall after you've sunk, an hour or so into the thing, just take a break. And then try it again the next day. If you don't make it by the deadline, try it again the next day and then the next morning. And ideally, you'll be able to finish each one. You have, 2 nights sleep in between there. You'll be able to finish each one before the next lecture. But you're working on it right after lecture and it's just not clicking. Well, yeah, that's just because you've been bombarded with information for 50 minutes and then you're trying to jump right into coding, which I recommend you do. You should start right away. But you should hit that brick wall. You just got a lot of content. Like, your brain needs a rest. When I just blast you 50 minutes, especially talking fast, your brain can't absorb and process that much content that fast. Just take a break. In order to complete homework expansions, we need to complete both homeworks, right? No. What is the expansion for Physics Engine homework? The expansion for Physics Engine it's in the assignment. Scroll down past the primary objective, you'll see it. So there are expansion objectives on some homeworks, not all. Like Rhyming Dictionary doesn't have an expansion objective. If you complete an expansion objective, you get one of your 2 expansion things done. If you don't want to do the expansion objectives or you only want to do one of them, you also have the option of doing an additional homework assignment to count for one of the expansion objectives. So if you do Physics Engine and Rhyming Dictionary, get them both done, then that counts for one of your expansions. If you do the Physics Engine expansion objective and don't touch Rhyming Dictionary, you also got one of your expansion objectives done way early in the semester, which will ease your stress later in the semester. If you do Physics Engine, Rhyming Dictionary, and the expansion objective of Physics Engine, you ain't got to worry about expansion objectives for the rest of the semester. You already got your 2 expansion objectives done. Hey, there's the right answer. Pagoy, Jesse, greater than. I would say just everybody, but I'll settle for all comp sci teachers. Choking, of course, if that has to be said. I have some wonderful colleagues. Can I use lecture to create Baka Mattel? It's some sort of ML. I mean, I don't. I'm not quite sure what you're asking. If you're asking if the lectures will prepare you for that, it won't get you all the way to doing ML. You have to do a lot of studying on your own as well. But I'd say you wouldn't be able to do ML without understanding at least most of the content of this course. If you're asking for permission, anything in my repo, it's a public repo. Everyone on the planet has access to it, and that's all fair game if you want to use it. If you're using large portions, obviously credit me as the author because that's copyright and theft and all that. But if you want to use that in your personal projects, if you want to pull like one class or a method or something, go for it. And of course, don't use it in assignments for other courses because that's AI. Like my outfit today. Oh, thanks. Should be in the same order. No, they have to be in the same order. So these two lists of sounds start with the same sounds. So it has to be in the beginning. Like they both have an S later. That doesn't count for the alliteration. So an alliteration is like two words with the same that have the same first sounds. Like all alliterations are like if I'm starting with that ah sound each time, all alliterations are awesome. That's four words that all alliterate with each other with at least one sound. So here I'm defining alliteration length as the number of sounds that are the same in the beginning of the word, but it has to be in the beginning. So if this had a different sound, if this K was an S, this would have an alliteration length of 0 because the first two sounds don't even match. It's not an alliteration.